All right, now that we had a introduction to work and power, let's talk about how we can get out of doing our work. A lot of times I don't like doing work because it requires me to apply a force over a distance, and that can be strenuous and even sometimes impossible for me to do. So I'm going to make a machine to do it for me. And I like that. It makes things easier. So let's look at this pile of dirt here. It's a beautiful pile of dirt, and let's say I want to move it somewhere else. Well, it's the same amount of dirt. I'm going to move it the same distance, so I'm going to do the same amount of work on it, but there are many different ways I could do that. So I could make use of my hands and just kind of pick them up handful at a time. I could invest in a shovel, which is a type of machine, or I could invest in a wheelbarrow, which is another type of machine. All of which may make this work go faster, but it doesn't necessarily mean I did less work. I'm still moving that same pile of dirt the same distance. However, it does make things easier for me. So a machine allows you to do work in a way that's just easier for you. Exerting a force at a distance can be tiresome, so let's make it easier. Instead of doing it a handful at a time, I can use this shovel and do it a shovelful at a time. It makes it easier. Therefore, my shovel's a machine. It does not, again, make less work, though. I'm still moving the same dirt the same amount of distance. So, how can machines make work easier for you? Well, they can do it three ways. One, they can change the amount of force you can exert, so I don't have to exert so much force, which makes life easy for me. It can change the direction that I exert the force, so if I exert a force upward, my machine could exert that in a downward force or other direction. Or it can change the distance at which I apply or exert this force. So again, these are your three factors that go into work, though. I mean, you can think about it. We have a direction, a distance, and the amount of force applied, all of which go into doing work. So what we have in a machine is we have inputs and outputs. We're going to put work into it, and we're going to get work out of it. It's pretty much that simple. And again, we have those two factors of work, which is force and distance. So I could exert a force on a machine. The force that I put into the machine, we're going to call an input force. And the force that or the distance that I move this machine is going to be called the input distance. The machine is therefore going to move a distance, and we're going to call that the output distance. And it's also going to have a force applied, which we're going to call the output force. So input forces and distance is what I put into the machine. Output distance and output force is what the machine produces. So let's do some quick math here. Remember that work equals force times distance, right? So my input force times my input distance is going to equal my input work. My output force times my output distance is going to equal my output work. Again, input is what I'm applying onto the machine. Output would be what the machine is applying onto whatever I'm doing work on. The amount of work can never be greater than the amount of input work. Unfortunately, because of our laws of conservation and friction and other forces that we don't normally account for, I cannot get out more work than I put in. In fact, I am probably going to get out less work than I put in. But it's still going to be easier for me to do, so I'm going to take it. So I can change force. So here's some examples of changing forces and how machines are going to change that force. Right? Our output force is going to be greater than our input force. That's the goal here. I want to be able to put in a little bit of force, and I want my machine to exert a lot of force. With doing that, I need to therefore give something up here. I need to change the distance that I'm applying. So if you think about this refrigerator, I could easily just pick this refrigerator up and stick it into this truck. I'm going to exert a large amount of force to move it upwards, and then I got to move a large amount of force to move it back because it's such a massive object. It's going to take a while for me to accelerate it, so I need to apply a large force. Or I could use this machine, and I could increase the distance I need to move it, but just apply a little bit of force. So I use this machine called an inclined plane, or this ramp right here. and I'm going to move the distance of this refrigerator from the bottom of that ramp to the top, which is a lot greater distance than just picking it up and putting it on, just covering that vertical distance. I'm going to cover this whole vertical distance as well as some horizontal distance here. I'm going to increase the distance I do, however, it's going to decrease the amount of force I apply on this object. Overall, it's getting to the same place, and therefore it's doing the same amount of work. You can also think of this as valves, like this is a water valve here. I'm going to exert a large distance as I turn this large wheel around. And inside this valve is going to turn a small wheel, but it's going to apply a lot greater force to this wheel because it has to counteract the force of the water that's rushing through this. So it's a lot easier if I apply a larger distance to it. So here I am decreasing the amount of force that I need to apply by increasing the distance that I move. I could also change the distance. In doing so, I'm going to have to give up something and apply more force to it. Here's some simple machines that you're probably familiar with. One is a hockey stick. This hockey stick takes a large force that you apply to the handle of it and increases the distance of the bottom of it, and therefore I can move the puck a lot more. Chopsticks, same thing. I use a small distance here but a large force, and I get a large distance and a small force. Last is direction. I'll move my face out of my picture there. Last is direction. I could apply direction different. This is pretty much a pulley when we get into pulleys, but basically when I exert a force downward, I want it to move upward. In this case, a lot of times I am not actually changing the distance I move or the force I apply. A lot of times it's just changing the direction. We'll get into that a little more when we talk into pulleys though.